One of the analogies that I've used for years to describe a production line is this. The line is my sandbox. As the systems integrator, the entire line is my sandbox. The conveyors, accumulation, fillers, case packers, palletizers, all of it. And if you're bringing a machine into that line, you're essentially playing in my sandbox. Now, that sounds super territorial, but it's not ego, it's really responsibility. And I didn't fully understand that distinction until I started living it on real projects. Welcome to From the Bucket, where controls design meets reality. I'm your host, Keely Smith. In this podcast, we explore industrial control systems as they exist in the field, not just how they were designed in CAD or how they look on paper, but how they operated in a production environment, how operators and maintenance interfaced with them, and the fun and interesting stories that I've made throughout the years of being a controls engineer. So, one of the machines that's always been tricky to integrate are fillers. And it really has nothing to do with the filler company and them being bad or anything. It's really because the fillers are a really critical machine. They're actually product touching machines. And the trick with being a product touching machine is that the manufacturer tends to be really 100% liable for what that machine does. So because of that, the manufacturers are really guarding of their logic. And my first two filler integrations were way different from each other. So the first one, it was seriously as easy as I think there was like one or two wires. I mean, I told the filler to run, I told the filler to stop, and that was it. And in a lot of ways, that's a really beautiful communication structure. There's no comms tables, there's no Ethernet configuration, there's no discussions over how we want to structure it, none of that. But on the flip side of that, you get nothing back. So there's really no runtime data, there's really no internal state visibility, no fault details. It's basically just a, hey, I'm telling you to run, and then just the assumption of, all right, I told it to run, so yep, it's probably doing something. And honestly, that kind of works. Like it's not a terrible interface, but one of the things that I've noticed throughout my entire career is that people want more and more data from their machines. They want to be able to pull this into reports and really analyze how their line's running. So with that type of really simple interface, that's kind of virtually impossible. And then you have the flip side where the second filler that I ever did, it was all Ethernet. So when you're really young in your career, that feels like a really big win. The Ethernet means extra flexibility. It means that, you don't have to really have a plan to be able to do something with it, because with Ethernet, you're just pulling more bits of data into your line as you kind of think of it. And the cool thing is that you miss something. It's not like you got to go and grab an electrician to go pull more wires. You just add another bit to what you're already pulling in. So in your head you're thinking, cool, I can pull whatever I want to because it's basically free. There's no physical component to it. And what I found out is no, that's not really the case. So just because you have Ethernet comms with a machine doesn't mean that you're going to have access to the machines. It really just means that your electricians don't have to pull more wires for whatever the OEM decides to give to you. You're still dealing with this product touching machine where the companies are still basically controlling the logic of what it is that you're going to get. So you still get that start, you still get the stop, and sometimes you get some very, very basic states like, running, stopped, faulted. But realistically, that's still it. Um, you know, you can sit here as the integrator and say, well, but I know that there's a ton of information in that PLC that is just sitting there and my customer wants it. But knowing that it's there and being able to actually pull and use that data are two totally, totally different things. So you may be asking yourself, why is this a real problem? Why is this more than just, yeah, you either can get more bits or you can't get more bits, and ultimately your line still runs. So here's the scenario I'm going to lay out for you. So we're going to talk about this in the context of some food and beverage lines that I've worked on in my career. And the thing of it is that your production line in food and beverage is typically not just one big open room. So it's actually physically divided into different zones. So, and intuitively, that kind of makes sense, right? So if your filler is this super sanitary machine that has to be kept to a very, very high sanitation, well, that's probably going to be in an enclosed room where you can actually control that environment. So a lot of times the filler rooms were the nice air conditioned room with HVAC, filtration, super sterile environment. The mats by the doors with the foam that cleans your shoes, like all of that stuff, which is great, right? You want that product containing room to be super sterile, which again, all this is really good, but until something goes wrong in that room and nobody outside really has what visibility into what's actually going on. On the flip side, say you're out in the palletizing area, that palletizing area could be half a mile away. I've actually worked in facilities where cases, after they were packed, they actually traveled close to half a mile to a mile on overhead conveyor to get to the palletizer. And the thing of it that is when we were doing that particular system, that case conveyor is 20 feet in the air. You can't see it. So like a short case would be below your sight line, even if you were standing there staring at it. So here's kind of what happens when you have no communication with the palletizer. It stops. Maybe there's a jam, maybe there's a fault, maybe there's just something stupid like it ran out of pallets. It doesn't matter because your line doesn't necessarily know that if you don't have any of that data. So what'll happen is everything keeps running. The line keeps running. Your conveyor keeps making cases. Everything keeps moving down the line. Half a mile of overhead just starts to fill up. And by the time your line full photo eyes triggers, which they might be 50 feet from the end of your line, you've already got 30, 45 minutes worth of production sitting on top of that conveyor. Now, your line's full and you have to shut down your filler. And one of the things that it's always kind of been driven into me from the very beginning of my career is on a food and beverage line, your filler is the only thing that makes money. So if you think about it, it totally makes sense because that filler is actually creating your product. So with that in mind, everything else on your line just costs money. So no matter what you're doing on the rest of your line, the whole idea is you need to keep the filler running. So one of the things that I am going to pause here and explain a little bit better because some of you might be listening and saying, well, if you have all this conveyor and you know that this is potentially an issue, why wouldn't you just add more sensors? And the trick here is when we talk about having half a mile or a mile worth of conveyor is you start getting really far away from your control systems. So with your case conveyor, you're typically just trying to get your conveyor from one place to another. So when you start talking about adding more controls to your case conveyor, it starts getting really complex because now you have to figure out how to get signals a half a mile to a mile away back to your main control panel so that you can start to have some of this data. But now here's kind of the important part to remember here is that your case conveyor is just that. It's just transport conveyor. And I hate to say this because it sounds terrible from a controls perspective, but statistically speaking, once your case conveyor is all set up, the chances of it actually having weird faults or any of that sort of stuff, it becomes a lot less. So realistically, the thing that's going to stop your line is your palletizer. So something's going to happen back there that will cause your line to back up and all this fun stuff. So with that in mind, that palletizer, if it has the right interface, I can know from half a mile to a mile away that, hey, something's going on in the palletizer and, we need to kind of keep track of what's going on here. Or in case of like some of the facilities I've worked at where they're running a very light crew back in palletizing, because generally the palletizers just sit there and do their thing, we can get somebody alerted to the fact that, hey, this palletizer went down and our overhead is starting to fill up, and we don't want to shut this filler off. When you look at it from that perspective, it's really not just like this philosophical argument about, oh yeah, more data is better at this point. It's really a production loss with actual dollar amounts associated with it when you're missing that data coming back to you. So like the other, I guess, version of this problem is for machines with, I'm going to call it restricted access. And I kind of laugh because I have machines in my mind when I say restricted access, that it's not necessarily that the machines have restricted access. It's more along the lines of the machine is a very tall machine. So you've got operator controls on the bottom and you have operator controls on the top. And with with the operator controls sitting on a 20-foot platform, you get into a situation where if the operators can't see basically what's going on up top on the bottom, well, there may be situations where things are happening up top that nobody knows about. And again, with kind of the right interface there, I can pull more of that data in. So, like I said, one of the machines that I kind of have in my mind is it was a 2-story machine, and there was a bottle strip off conveyor at the end. And every now and then, a bottle would get kind of caught at the end of the machine. Now, the interesting part here, and realistically, I mean, there was probably a little bit of a failure of controls here on both the integration and the machine builder side, because the way that the bottles could get jammed was in a way that was really difficult for either me as the integrator to detect and them as the machine builder to detect. But the thing is that even if it's hard to detect, there's still signs. And some of those signs come from basically your machine status. So what you would see basically from the machine is that the machine was waiting for the downstream to be ready. From the line control side, you would see that our overhead is empty. So with those two pieces of data, it would kind of narrow you in on, well, wait, if the machine says it's waiting for the downstream and the downstream is saying that it's basically waiting for the machine, we know that something on the in feed of the downstream is going on. But here's the thing. This machine didn't have any of those status bits being sent to the downstream. So basically what would happen is this jam would occur. The machine wouldn't say that there was a problem because it was just saying that it was a downstream problem. From the line control side, we didn't have any information that was saying, "Hey, there's actually like a jam on on this machine." So more than once, it would just result in people kind of looking around like, "Oh, I don't know what's going on," and getting the operators to climb up these up to this 20-foot platform. Uh, it it sometimes would take a while because who wanted to climb up to this the top of this platform and actually look around. So this example is kind of ridiculous because you have this situation where it's hard to detect in the first place, but with just a little bit more of that data, you can start to process what actually is going on, and if nothing else, narrow it down to a specific spot where, hey, something's going on here because we kind of don't have data, but you need the absence of other data to kind of make that. So now it sounds very convoluted because now I'm saying that sometimes the absence of this data is how you can help determine what's going on. But that's again with the assumption that I have the data that says the machine's running, it's not faulted, all of this stuff. So again, as the integrator, I can take that and say, okay, well, if you're running and you're not faulted, but you're not sending bottles, well, that means that something is happening between where your machine ends and my system begins. And when you start to kind of look at it from this perspective, it's kind of when it clicks. It's not that Ethernet means that it's we've got good integration. Ethernet just means that again, we're not pulling all these wires, but the the thing is that integration really means alignment. And that's a really kind of powerful thing to understand because at the end of the day, I can do the same thing with Ethernet that I can do with hardwires. So it's not that one of those interfaces is better or worse than the other. It really just means that with those two different types, I have a different media to get the same results. But at the end of the day, I still have to have that alignment between myself as the system integrator and the machine builder. So one of the funny things that I'm going to talk about that is I can just imagine that people are going to listen to this and say, really, really. But on the same project that I was fighting with the different fillers over the data, I did have a machine that did it in my opinion, and I'm gonna really preface this of in my opinion, they did it completely right. And that machine natively implemented PackML. And again, I have to laugh here because I know so many engineers that uh, know about PackML and they absolutely hate it. Which, to be totally honest, the first time I saw it, I kind of hated it. I thought, what is all this stuff? This is like a crazy amount of data. Why did they do all this? But here's the thing, PackML is a very, very complete standard. It goes way into more of the details than you typically need for a basic machine interface, but it's beautiful because it is such a complete standard. When you're new and you're used to just wiring in a dry contact and calling it a day, seeing a full PackML implementation just feels like overkill. But PackML, like I said, this is why it's so cool, because in a lot of different areas, and I'm not even going to pick on food and beverage here. I'm going to pick on uh, pretty much every industry that I've worked in. There's not a ton of like really governing standards of how you uh, accomplish a task. So there's really no overarching body of standards that say this is how your machines should talk to each other. So a lot of what we as integrators do is basically create, the standard that we're going to follow for our projects from scratch on basically every project. So again, what makes PackML so different is it's actually a real standard. It's a standardized way of looking at machine to machine interfaces. It defines your states, your transitions, your fault handling, all of it. And it does it in a way that, if you had a line that everybody implemented PackML, it could be a absolutely beautiful line, because you have this really standardized way of looking at every single machine and know what the machine is doing. And again, as an integrator, that's really cool because it's something that remains constant from machine to machine. So once I actually understood what they were trying to accomplish with this standard, it truly completely changed the way that I thought about integration. Now, I'm not going to say that, I started implementing PackML on every single one of my projects, because that's just not. You have to build your machine around PackML, and that's not going to happen for a lot of machine builders. They're using machine code that they've built many years ago. They're taking basically the same thing and they're applying that same machine to different scenarios. So in order to do a true PackML implementation, you'd basically have to start from the ground up. But what I did was I took the PackML standard and I stripped it down into the parts that I actually needed for my machine status. And then I would take that simplified version and I'd implement it in my own software. So when I started getting involved in the projects on the front ends, I could have these conversations with the integrators of, hey, this is what data I'm looking for from you on status. So I could break down like this when you send me this number, say you send me a 3. Well, now I know that your machine is faulted. And the cool thing with this was now I can start sending that out with all of our RFQs for the machinery. And when it comes back and we actually implement all of this stuff and we integrate this line, we're already set. I already know what this data looks like and where it's coming from. And surprisingly enough, the reception was really good. And the reason is really simple. Vendors hate having to try and figure out the interface between their machine and the integrator out in the field. By the time you're on site and building the line, their focus is really on getting their machine up and running, making sure that everything is exactly the way that it was during your FAT, and then going home. So the thing is if you have that clear documentation up front before anything is even built, everybody is on the same page before that machine even ends up on site. So that really changes what your on-site integration looks like too. It actually makes it a lot easier and faster for everybody. So I do want to go back and talk about the my analogy of playing in my sandbox, and if you're going to play in my sandbox, this is how you're going to do it. And I do really want to dive into this a little bit deeper and talk about the ego component to all of this, because you hear that and it's like, oh, okay, well, this is just a controls engineer with an ego trip. But it's really not. The whole reason behind it is, you know, it's about the responsibility of who has to basically live with this line after the machines are integrated. Because if you break it down into something really simple, the machine builders are responsible for their machine. They own the sequencing, the safety, the internal process integrity. You know, all of that stuff is, that's where they're concerned. They are, in a sense, they're liable for their machine. But what they are not really paying attention to sometimes is the rest of the line, because they're not responsible for the rest of the line. They don't actually need to, in a way, care how their machine interacts with the next one or interacts with the line control, because it's outside of their scope. So you have to kind of take it with a grain of salt when I say that, it's my sandbox and you've got to play in my sandbox the way I tell you to play in my sandbox. Because while you don't care, I do care, because I am the one that's got to be responsible for making sure that their machines do talk to the other machines and do operate with the other machines in a way that allows the line as a whole to be successful. So now we're going to kind of do a really, really big pivot here, because, this whole episode we've talked about data, 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 and how data is great and having this visibility into the machines are great and all that stuff. But I think that there's some really important caveats here, because when we talk about visibility, visibility is different than control. And one of the things that I didn't really understand that well early on was visibility and access are two very different things that are very easy to kind of muddle the lines with, because there is a fine line between not enough control and too much control, and that all comes from what you can access. So, for example, too much access to something could look like this, where I can reach into the machine, I can stop the individual internal processes. I can, if there's a machine that has 10 different internal processes, and I can manipulate any of those from the system PLC, that's too much control, because now if there's a fault or a problem, whose fault is it? If I stop something out of sequence and the machine behaves poorly because of that, is that a machine problem or is that a line control problem? So again, there's this really, really thin line of too much and not enough. And I'll make the argument that visibility is pretty much going to be uh, fine. No matter how much visibility you give me into your machine, that's fine. But the access and being able to touch internal process inside of your machine, that's way more than as an integrator I really should have access to, because if I can do something that controls or changes the controls for an internal process, that's not integration. Now we've created an interface where I have direct control of your machine. So, and I think that it's one of those things that, as you gain more knowledge and maturity within the integration, uh, you get a lot better at defining these boundaries clearly. Where I say, I want this visibility, but, you as the machine builder still own all of your internal sequencing. I don't own any of the internal stuff. My whole thing is I just need to be able to coordinate the systems together. So I need to understand the visibility of the states. I just don't need to have basically my hands inside of your machine doing stuff inside of your machine. And then there's always one of my favorite conversations, and I, if you can't tell, that favorite is absolutely dripping with sarcasm, and it's the "that's not in my scope" conversation. And here's how it usually goes. So the customer has an idea of what they want. Uh, Me as the integration company goes and finds a machine that fits the project, but there's a lot of times not a a controls person involved with some of these really early on conversations. So when you have a situation like that, you show up on site, machine's already bought, contracts already signed, and you as the integrator go to the machine builder and say, hey, you know what, I need this data. You know, uh, they can look at you and say, well, you know, that's not in my scope. I'm here to start up my machine, and that's it. And here's the kicker here is that technically they're right. And not there's not a lot of companies that I've worked with that are like this, but there's enough to where I've had this conversation enough that the process at that point becomes uh, pretty cut and dry. So we take it back to the customer and let the customer know, like, hey, this vendor is saying, nope, we're not pulling this data. Nope, we're not doing this. Whatever. So then the customer goes back to the vendor. The vendor comes back with a change order. The change order goes through the customer. Customer approves it, and then we start to move forward. Which, okay, cool. So we have a resolution, but the problem is that we just burned 2 or 3 days on a project. So like I said, this has happened a few times throughout my career, and it's stuff that again, the more mature you get in your integration abilities, the more you can help to kind of mitigate this. But it still happens. But then there's the vendors that just flat out say no. And it's not just okay, here's a change order. We'll give you the data after the change order. It's just no. This is what you bought. We're not going to come and make the changes. We're not going to do this stuff. So it's interesting because it's a situation where it's not super cut and dry, because a change order is not guaranteed. Just because you go and throw more money at a vendor doesn't necessarily mean that they're going to go and fix it. So you're left with some interesting routes at this point. So we kind of already talked about the diplomatic route where, we go through the whole change order process, and basically the end customer starts to throw their weight around of like, you know what, we just bought this $2 million machine from you. Um, are you really going to not do what we're asking for, even when we're offering you more money to do it? Because a lot of machine builders, when they're approached with that conversation, they have that choice of, well, do I really want to burn this relationship over what's maybe $1,000 change order? But again, sometimes the diplomatic route doesn't work, and it's especially with the machines that say they are like this canned machine. This company's pumping out, I don't know, 1,000 of them a year or whatever, and maybe they just don't have the people that can make these changes available. So in those cases, you start to get a little bit creative. So one of the vendors that I had done this with, they just flat out refused. They said, the machine was their machine. We're not going to get the integration the way that you need it. Um, you bought what you bought. So again, here's where things had to get a little bit creative. So we looked at what their code was actually doing and figured out, this sensor does this and this sensor does this. So, we took their sensors and we basically started splitting it apart, and we used RPLC to basically mimic their sensors. So if they had a sensor that would, for example, stop the machine, well, I could take a cable from my system PLC and I could actually like almost in a way spoof that signal. So I would bring the data in from my line and I would use that. I'd run the logic inside of my line controller and then I would just give them the signals that they required through that sensor cable that I took their sensor off of. So, sure, at this point, this is a really convoluted way of doing it, but it's it works within the parameters that you gave us. I'll use the phrase malicious compliance here. So basically, you said you won't integrate with me. So okay, fine. I'll just integrate around you then. So I guess looking back at all of this, it never really was about hardwires versus Ethernet. It really wasn't about PAC-ML. It wasn't about vendors that worked with you or the vendors that said no. It was really about learning what that integration responsibility means and how you achieve that alignment. You know, it's understanding that the machine builders are going to protect their machines. The system integrators are going to protect the flow of the line. And if you don't really define where the responsibilities overlap, and here's the key thing, it has to be early in writing before anything is built. You're going to define it during that startup, and you're going to define it during your downtime, because I couldn't just say like, yeah, this is my sandbox. You have to play in my sandbox the way I tell you to. You need to figure out an alignment between you and the others so that everybody was playing in your sandbox the way that they needed to make sure that their stuff ran the way that it needed to, but still with that way of uh, working within the flow of the line. And sometimes when that alignment wasn't possible, you find another way. And that way of thinking, where you need to get all of this alignment, it really is something that I carry with me on every project that I do today. This has been From the Bucket, where controls design meets reality. Until next time.